In today's lesson, we will be graphing linear functions, and we have graphed them before. In our last unit, we would make XY tables, we would plug in values for X, and then solve for Y, and then plot the points. But instead of doing that, we're going to do different steps that is actually less work, and you can graph the lines a lot quicker. So for today, all of our equations are going to be in this form, y equals mx, which means they do not have the plus b at the end. And what that means, if you remember, the m is your slope. So whatever number is in for m will tell you how to do your rise over run to graph your line. And then because we do not have this b value, that means our y-intercept is going to always be at the origin 0, 0. So when graphing lines, the first step is to plot the y-intercept. And in today's lesson, our y-intercept is always going to be at the origin 0, 0. And then we need to find the slope in our equation, which is m, in the equation y equals mx. And then we're going to use our slope and the idea of rise over run to plot the rest of our points. And then you might want to make yourself a little note that if your slope is positive, you will always go, you'll always at least start going up and to the right. But if your slope is negative, you will start by going down and to the right. And I will explain more about what that means, but the key thing is either up to the right or down to the right, and that will help you keep your positive and negative slopes going the right direction. On each graph, we're going to graph two different lines, just so we can get more practice. The first one, this blue equation, y equals 1/2 x. First step, plot the point at 0, 0. And then our slope is 1 over 2. And if you think of rise over run, and if you put our fraction 1/2 next to it, that is telling you that from the origin you're going to rise 1, run 2. And it's positive, so you're going to go up and then to the right. So from the origin, I'm going to go up 1, right 2, plot another point. Up 1, right 2, plot another point. Keep going across the entire graph. Follow the pattern. Up 1, right 2, up 1, right 2. And now, after you have gone in this direction, now you can go backwards, where we'd have to go down 1, left 2. Down 1, left 2. And now we have dots across the entire graph. We can connect them to a straight line. Let's do the same thing with the equation y equals 2x. Same thing, our point is at the origin. If you think rise over run is a fraction. And the number 2 is not a fraction, but how can we rewrite it as a fraction? It can just be 2 over 1. And this one is also positive, so you're going to go up and to the right, but this time up 2 over 1. Up 2 over 1. Up 2 over 1. And you can continue that pattern. And then when you go backwards, it'll be down 2, left 1. After you graph every line, just always double check left to right. Are you going uphill or downhill? And both of these are going uphill, which makes sense because our slope is positive in both of our equations. Alright, now let's graph these two equations. Both of these have a negative slope, -2/5 and -5. So the first step, we're going to plot our y-intercept at 0, 0. And in our blue equation, rise over run, is negative 2/5. So if my slope is negative, the pattern will be you're going to go down and then to the right, always to the right. So starting at the origin, I'm going to go down to right 5. And then follow that again, down to right 5. And now worry about going backwards, up to left 5. Up to left 5. And then you can connect all of them to make your line. Alright, and now the red equation, rise over run, it's negative again. And what do we do when your slope is not a fraction? It's an integer, negative 5, we can write that as over 1. So we're going to go down 5, right 1. And starting from the origin. Down 5, right 1, down 5, right 1. And if you go backwards, you have to go up 5, left 1. Up 5, left 1. Connect and you have your straight line. And then if you think from left to right, you're going downhill on both of these, which makes sense because they're both negative. For these two equations, why don't you pause the video and try to graph them on your own, and then come back and check your answer. And in the very last example, I will show you two quick special cases. But in this case, just make sure you notice that one has a positive slope and one has a negative slope. So you should have graphed a positive kind of steep line for the blue equation, up 4 over 1. And then for the red equation, it should be negative down to the right, and it's more of a gradual slope. And here's our very last graph, the equation y equals 0.3x. So this time we have a decimal, which makes things a little bit more complicated, but not too bad. We don't really want to think about going up 0.3 over 1, up 0.3 over 1, but how can we rewrite this equation? 0.3 is 3/10. So if we rewrite this as y equals 3/10 x, now we can graph a better equation. So we're going to rise 3, run 10. Up 3 over 10. Down 3, left 10. Draw your line and double check. It is positive, and from left to right it is going uphill. So it works. So there's your full lesson on graphing equations where the y-intercept is 0, and then you use the slope to get your other line, to get your other points to graph your line.